Okay, this is another battery update. The batteries have been off of both grid power and four-phase power, the new power, superconductive grid. This battery is Faraday. This battery is Pucta. This battery is Pucta. This battery was clearly dead. That's why I had to get a new phone. But now, just with a short charge, as you can see there, now the battery has 5 hours capacity at 38%. So we have to compare that to the last video. This is just an update. Nothing's going to run right now. We're just going to let these stabilize because I want to show you something more important. I want to make this video efficient. So now we have 92%. This battery was 100% charged. It's lost 8% of its charge just by sitting here. And it says it has 46 hours left. And here's since the last time it was fully charged, 22 hours ago. Okay, so nothing has changed. That's the same time as the last video. Now, this one says the same time, 3 days since fully charged on the battery. Like I said in the other videos, I apologize, I misread this, but that's fine. These videos are live opens for a reason, so we can document what's going on without any switch of hand. Now this battery says 54% at approximately 27 hours left, but it predicted for the battery to be dead at 10 p.m. And if you look at the last video, it predicted the battery to be dead, but it's obviously holding some density in the battery. And we have to go back to the understanding of graphene being 2350 nanometers or meters squared density. Carbon is 900 meters squared density. And if you can see the time from the last video, this charged very fast. It took a little longer to charge this battery. So now we are technically on the #1 cooling cycle. We already did the heat cycle in the last couple videos. So we're going to keep going on the scientific method that I understand, and we're going to go through 3 heat cycles. And then my understanding will be, my prediction is that the battery, once the graphene in the electrolyte, the carbon in the negative electrode, whether it's carbon or graphite, will definitely go to graphene. Then the carbon that's in the lithium will go to graphene. Now you have to remember something. What we're trying to show is that these batteries will superconduct close to room temperature, helping the implementation of the biogem chip that will self-charge these. However, you have to bring yourself down to one very important point. During all of the cold fusion yondra, they used lithium salt. They got a back EMF of 750 of a second, 0.750 of a second. That's all they got in the fusion reaction. However, it created an exothermic reaction to create heat. So that exothermic reaction is brought on by the AC wave, not the longitudinal node or mode. The node is one wave. The mode is back and forth. So when that happens in the lithium ion battery, the CO2, the carbonate of the lithium, produces the nanotube little trees. I apologize, forgot the name of them. Produces those trees that nobody can stop. Okay? and they grow and they shunt the battery. That's what kills the battery. If we've reduced that growth, that's why this battery is coming back. That's what the electron microscope is going to show us. But we're going to keep these intact, and these will be our controls. Then we'll abuse these and see what happens. Okay, so that's your update. We're not going to turn on any power of these today. And in fact, because I have to do something, I'm going to disconnect them because I don't even want the transformers to have a charge. Give me a second. Because I want to show you something very important. Okay. Now they're completely disconnected and this power is off. So I need to disconnect this one because I need to turn on the oscilloscope. Okay, this one's now disconnected. So I need to turn this one on so I can have the oscilloscope. Pardon my disorder here. Now there's no electromagnetism going around. But here's the power on the oscilloscope. I want to show you this. You see that? That right there is just about, let's see, about everything that you need to know about superconductivity. That's a longitudinal node. Look at the power that the generator is now producing. Over time, it's getting better and better. These are the millivolts coming right out of the generator. We can turn off the oscilloscope. And the millivolts are still there. Okay? The ohms meter is off. We're not inducing through the ohms meter. The amp meter and the temperature meter is off. Okay, there's no other power coming in. This is the definition, ladies and gentlemen, of superconductivity. It's getting better